Hello everyone, and welcome back to another episode of Math with Dr. War. In today's lesson, we're going to focus on exponential growth and decay, a high emphasis topic on the TASC test. Now, exponential growth and decay basically means you have a quantity that is increasing or decreasing by the same percent. Now, in some textbooks, they give a general formula for exponential growth and decay, which is y equals to a 1 plus or minus r raised to the t. Here, I have split them into two. In exponential decay and growth formulas, the y is considered your final amount. However, I like to call it the total amount. The A is the original, or what I like to call the initial value. The R represents your rate, which is a percent that has been converted to a decimal. The T represents your time. This is usually in years. And the 1 plus or minus R, depending whether it's a growth or a decay, is what we call a growth factor or a decay factor. Now notice that when it's a growth, you have 1 plus your rate, and when it's a decay, it is 1 minus the rate. Now the 1 plus or minus R is considered your base. So sometimes we call that the base. The base can identify whether you have an exponential growth or a decay. If your base is greater than 1, that signifies a growth. If your base is less than 1, that signifies a decay. Let's look at the two examples below. It states to rewrite each function, determine whether it represents an exponential growth or an exponential decay. So I look at my function and I go to my base. So my base here is 0.96. Now I know 0.96 is less than 1. This indicates a decay. So A is an exponential decay. Now if we want to rewrite our function, such as the original formula, it would be 100, 1 minus. Now we have to figure out what our rate is. The 0.96 is your decay factor. So to figure out my rate, I'm going to take 1 and I'm going to subtract 0.96, which gives me a value of 0.04. And all of that is raised to the t over 4. The 0.04 is a decimal, and if I change it to a percent, that is simple. I'm simply going to move my decimal point 2 places to the right. It's 4%. So this exponential decay function, its quantity is decreasing by 4% for each time period. Let's look at B. I have f of t equals 1.1, and that's raised to the t minus 3. Again, I'm going to look at my factor. I'll call it my base factor. It's 1.1. 1.1 is greater than 1. So if your base is greater than 1, that indicates a growth. So this is an exponential growth. Again, if I want to rewrite this like the standard formula, it would be 1 plus, and I have to figure out what was added. To do that, I'm going to take 1.1 and subtract it from 1. That gives me a value of 0.1. So 1 plus 0.1 raised to the t minus 3 gives us our growth factor in the expanded form. So you don't need to expand it. You can basically look at your base. If your base is less than 1, that represents a decay. If your base is greater than 1, that represents a growth. And remember, exponential growth means that the quantity is increasing by the same percent each time period. If it's an exponential decay, it means the quantity is decreasing by the same percent each time period. The key thing about exponential growth and decay is that you're either increasing or decreasing by the percent. You start an account with $500 and an interest rate of 6% compounded yearly. How much is in the account after 3 years? Would this be considered an exponential growth or decay? Keywords in the problem will help you identify. Now, because it says it's an interest rate, we know interest always increases the value or the value of the item. This represents a exponential growth. The initial amount would be your original amount, which would be $500. We have to identify the growth factor because we know this is not a decay, the growth factor. Remember, the growth factor would be 1 plus R because it's a growth. So it's going to be 1 plus your 6%. But remember, we need to change that 6% to a decimal. So we have our 6%. To change it to a decimal, you're going to insert your decimal point and move it 2 places to the left. I'm going to add 2 zeros. 1, 2 is going to be 0.06. And when I add it to 1, it's going to be 1.06. So my growth factor is 1.06. If you're not comfortable with changing your percents, moving the decimal point to the left, you can use your calculator. If you take your calculator, remember 6% means 6 over 100 because percent means per 100. So if we put 6, N over D, and 100, we go to the right and we hit enter. Notice it changes it to a fraction in the reduced form. And to get our decimal, we need the toggle function. You press the toggle, you get 0.06. Now this is only if you're on the calculator section. Now there's some folks who don't like the fraction function. If that is you, in the calculator, just enter 6 divided by 100. And hit enter, and you get your value. Now we have to write the exponential function. Remember the original function, and this is not given to you on the reference sheet, is y equals to a 1 plus or minus r raised to the power of t. So y equals, our initial value is 500. Our growth rate is 1.06. And our time is 3 years. And they want us to do the math. This will be on the calculator section because this is a lot of multiplication. And remember, the TASC test is timed. So we would enter 500, open parentheses, 1.06, close parentheses. Let's use the, I'm going to call it the arrowhead. I always forget the correct term for it. My students call it the arrowhead. And 3, which is our exponent, go to the right and we hit enter. And I get a value of 595.508. Because this is money, we're going to have to round to the nearest hundredth. So the 0 here is in the hundredth, and that 8 would make that a 1. So our answer, 595.51. It says here the value of a car purchased for $20,000 decreases at a rate of 12% per year. What will be the value of the car after 3 years? So we know that it's going to be y equals to a 1 plus or minus r raised to the t. Is this a growth or a decay? Now, because of the word decrease, it indicates that it's going to be a decay. So it's going to be y equals to a 1 minus r raised to the t. What is your A? The initial value, which is 20,000. 1 minus, your rate is 12%. You need to change it to a decimal. So let's put in our decimal point and move it 2 places to the left, 1, 2. So this is going to be 0.12. So this is 1 minus 0.12. The time is 3 years. So this is 20,000. 1 minus 0.12 would give us 0.88 to the third power. And we're just going to pull out our calculator. Let's clear. And we're going to insert all of that in there. So it's going to be 20,000. Open parentheses. 0.88. Our arrowhead. And we're going to raise it to the 3 years. And press enter. Our answer is $13,629.44. So our answer is number 2. And we're finished. Now, most of the problems that you will find on the TASC test on exponential growth and decay will be interpreting or setting up the problems. So here we have a setup. Mr. Smith invested $25,000 in a savings account that earns 3% interest compounded annually. He made no additional deposits or withdrawals. Which expression can be used to determine the number of dollars in this account at the end of 4 years? So remember, our formula is going to be y equals a 1 plus or minus r raised to the t. Now, because it's an interest, it's going to be a growth. So it's going to be 1 plus r raised to the t. And again, your test is multiple choice. So there are a lot of stuff here to help you. Now the initial value is 2,500. It's going to be 1 plus. Now your r is 3%, which we need to change to a decimal. So 3%. My decimal point is here. I'm going to have to move it 2 places. So I'm going to go 1, 2. So it's going to be 0.03. And the time is 4 years. So we're looking for a function that looks like this. We can eliminate 3 and 4 because their time is 3 and it says 4 in the problem. And looking at 1 and 2, we can clearly see that number 1 matches our function when we wrote it. The population of a city can be modeled by PT equals to 3,810 times 1.0005, and all of that is raised to the 7t. Where PT is the population after t years, and they want to know which function is approximately equivalent to PT. So they wrote the function for us, so we have to figure out which of these is equivalent. Now I notice with 1, 2, 3, and 4, the 7 has disappeared. Well, it hasn't actually disappeared. It's being embedded into the base. Now I can exclude 3 and 4 because 3,810 is your initial value. Your initial value does not change. So that's why I'm excluding 3 and 4, because our initial value was not 26,670. Now our base was 1.0005 raised to the 7t. And what they did is they took that 1.0005 and raised it to the 7th power. And we have to evaluate that. So we need the calculator. I'm going to take 1.123 zeros with a 5. We need the arrowhead. Raise that to the 7. Let's go to the right and hit enter. And it gives us a value of 1.0035. Which means our answer is number 2. Now, I did not need to use the calculator. 1.0005 raised to the 7 will increase the value of my base. Now, if you notice, for number 1, the base looked like it decreased. This is now 0.1427, which is less than 1. So I didn't need the calculator. I could tell right away my answer was going to be number 2. The equation A equals 1,750 times 1.04 raised to the power of t represents an account balance t years after the account was created. Which statement is correct? Now it looks like they're focusing on the factor, the base factor. Now because your base factor is greater than 1, this is a growth. So I can eliminate A and I can also eliminate C because of the word decrease. Now your growth factor is 1.04, and I'm going to unpack this because remember your growth factor is 1 plus R. So this is 1 plus 0.04. And again, how did I get that? I took my 1.04 and subtracted 1, which gave me 0.04. Now you must remember, we can't use that. That is not your percent. We have to change this decimal to a percent. And to do that, you're moving your decimal point 2 places to the right. So this is actually 1 plus 4%. Our account is increasing each year by 4%. So our answer is D. The depreciation of the value of a certain model car can be modeled by the function dt equals 0.92 raised to the t, where dt is the value of the car and t is the time in years. What is the percentage change in the value from one year to the next, and does this represent exponential growth or decay? So again, focus on your base. It is 0.92, which means it's less than 1. And anything that's less than 1 is a decay. So our answer is not B and it's not D. Those can be eliminated because they state growth. Now, is it an 8% or a 92%? I always tell my students when they're doing these problems, never choose what's in the parentheses. It's not 92. So we all know that the 0.92, we need to unpack that, which is actually 1 minus R. We got to figure out what the R is. And to do that, I'm going to take 1 and I'm going to subtract 0.92, which gives me a value of 0.08. So this is actually 1 minus 0.08. And remember, this is a decimal. And when we change it to a percent, it's actually 1 minus 8%. So our function is decreasing by 8%. So our answer is A. A website tracks the number of users it has at the end of each of its first 30 days since going online. The equation y equals 15 times 1.03 raised to the x shows the relationship between the number of days since the website went online, x, and the number of users it has, y. What does 1.03 represent in the equation? Now remember, exponential decay or exponential growth means that your quantity is increasing or decreasing by 8%. With that being said, I'm going to eliminate A and B. As A states the number of users is increasing by 3 each day, and B says the number of users are increasing by 103. You must increase or decrease by 8%. So your answer is either C or D. The 1.03 is your growth factor, but we know it is not increasing by 103. When you unpack this, it is actually 1 plus your rate. So if you take 1.03 and subtract 1, you're going to get 0.03. And remember, that is a decimal. And when you change it to a percent, it's actually 3%. So this is 1 plus 0.03, which is your 3%. Each day after the first, the number of users is 3% greater than it was the day before. Some banks charge a fee on savings accounts that are left inactive for an extended period of time. The equation y equals to 5,000 times 0.98x represents the value y of one of the accounts that was left inactive for a period of x years. Now they're asking what is the y-intercept of this equation and what does it mean? We have y equals to 5,000, 0.98 raised to the x. Now remember I told you that the 0.98 is your factor, and for us, because it's less than 1, it's a decay factor. The 5,000 is our initial amount. Now the 5,000 is our initial amount, and it's also your y-intercept. So anytime the question asks you about the y-intercept is your initial amount. It can't be the 0.98 because I've pointed out time and time again that it is your factor, could be a growth or a decay. In our problem, it is a decay. So which means the 5,000 is your y-intercept. So we're going to eliminate 1 and 2. The 5,000, is it 3? 5,000 the amount of money in the account initially? Yes. It is not 5,000 the amount of money in the account after X years. After X years would be the total. So that is not your answer. Okay, last two. We have a graph and a chart, and we have to choose the correct equation. So it says which equation best models the data in the scatter plot. Here we have a scatter plot with various dots on our graph. Now, if we try to connect the dots, notice that it seems like they are decreasing. Remember, when you're reading a graph, you read from left to right. Or think of yourself here walking down your graph. Now, you're going down, you're not going up. So you're decreasing, which means that your growth factor has to be less than 1. So decreasing. So your growth factor has to be less than 1, which means my answer is not B. So let's exclude that. And we're going to also exclude D because look at the growth factor. It is 5, which is greater than 1. Now, we need to find our A. Remember, A would be our y-intercept if it's a graph. And when we drew a line to connect some of the dots, our y-intercept looks like it's between 0 and 1. The only number here that's between 0 and 1 is 0.5. So our answer is C. Here we have a table which contains some points on the graph of an exponential function. Based on the table, which function represents the same relationship? So we got to figure out whether f, g, h, or j is our equation. We need to find our A. And our A is our y-intercept. And remember, when it's a table, your y-intercept is 0, b. X is 0 and you have a value for y. Right here is your y-intercept, which means this value right here is your A. Therefore, your answer is H. We don't even need to find the factor. Now you can tell that your factor is a growth factor because look at your values. They are increasing. 0.25, then 1 and 4. So your growth factor has to be greater than 1. This is less than 1, eliminated, less than 1, eliminated. This is your answer. So to figure out your growth factor, you can basically look to see whether your graph is increasing or decreasing. And to find your A, which is pretty simple, you're just looking for your y-intercept. And remember, in a table, you're looking for a 0 in the x position and then a value for y. If you see that, there is your y-intercept. Exponential growth and decay are two high-emphasis topics on the TASC test. I hope this has been helpful. Good luck on your TASC examination.